Study guide for section 7.3, we're going to look at inequalities within a triangle. They tell you all this information that you need to know. If you want to put the angles in order, you list the sides in order, and the angles that are across from the smallest side, the angle that's across from the smallest side is the smallest angle. The angle that's across from the biggest side is the biggest angle, and vice versa. So this is a lot of good information that's a review of the lesson. For each triangle, list the angles in order from least to greatest. So they give you side lengths. You don't know the angle measures, but you do know that this is the smallest side. And notice how it's listed in centimeters. That's how I know it's a side. The angle that doesn't touch this side is the one that's across from it, angle V. Angle V is the smallest angle. The next smallest side is segment OV, and it doesn't touch angle M. So across from this second smallest side is the second smallest angle, angle M. This is the biggest side, segment MV. Across from that is the biggest angle, angle O. We're going to use compound inequalities to show least to greatest. This is the smallest, this is the biggest, this is in the middle. This is how you read this. Angle O, its measure, we should probably have a measure there. Measure of angle V is less than the measure of angle M, and that's less than the measure of angle O, because these are numerical values. Even though we don't know them, we can put them in order. We'll skip down to number 4 and we'll use the converse of this same theorem. We're going to list the sides in order from least to greatest. So they give you 3 angle measures. We don't know the side lengths, but we can put them in order. If this is the smallest angle, angle E, then this is the smallest side. Segment AD is the smallest, so its measure is the smallest. This is the next smallest angle. Segment DE is the next smallest side. That's your biggest angle. That's your biggest side across from it, segment AE. Again, we're going to use compound inequalities. The measure of segment AD is less than the measure of segment DE, and that's less than the measure of segment AE. That's how you read that. Smallest, largest, in between. Now, these other problems follow this exactly, so you should be able to handle those pretty easily. Next section, list the sides of triangle ABC in order from longest to shortest if the angles of triangle ABC have the indicated measure. So now we're going longest to shortest. We have 3 angle measures. We don't really know what they are. We have an expression for each. What do you know about the 3 angles of a triangle? These are the kind of things you have to think about on your own if you're going to write an equation. They got to add up to 180. So this equation is going to let you find x, plug back in, and find the angle measures. And once you know the angle measures, then you can put the sides in order. Okay, so let's combine like terms. We have 6 terms on the left side. That's a lot of stuff. 5x, 6x, 1x. Just watch your signs. That's 12x. We also have a 2, a 20, that's 22, 22 minus 10. We'll subtract 12 from both sides. And then we'll divide by 12. How many times does 12 go into 168? 12 goes into 16 one time with 4 left over. Bring the 8 down. How many times does 12 go into 48? 4 times. So that's your value of x. Now you need to take that value of x and plug it back in. I'm going to use the calculator for that. Let's find the measure of angle A. So we're going to do 5 times 14 plus 2. Let's try that again. 5 times 14 plus 2. And that'll give you 72 degrees. That's the measure of angle A. Let's find the measure of angle B. 6 times 14 minus 10. That'll give you 74. 14 plus 20 gives you 34. So we know the angle measures now, which is really important. They want you to put the sides in order. They want them in order from longest to shortest this time. So longest would be across from the biggest angle. If your biggest angle is angle B, then your biggest side would be segment AC. That's your next biggest angle, angle A. So your next biggest segment would be segment BC. And then your smallest segment would be segment AB. So we're using compound inequalities. We want greatest to least. I'm pointing this way this time because this tells me the measure of segment AC is bigger than the measure of segment BC. The measure of segment BC is bigger than the measure of segment AB. Biggest, smallest, in the middle.